Have you ever found yourself looking at a moving object and thinking, I wonder how many feet that object is covering each second? Or even better, I wonder how many feet per second that object is covering per second. Okay, so you may not care, but College Board does, so it's best to be familiar with them. These concepts are called velocity and acceleration and are often associated with a type of math called calculus. And if calculus could be summed up into one word, it'd be derivatives. A derivative is used to demonstrate the rate of change or slope of a function. So, for example, if I am driving a car and my speedometer reads 60 miles per hour, that is the rate of change. Unfortunately, there is not a speedometer that can give us the derivative for every equation, at least not for the AP exam, so calculus provides us with a couple ways to derive a given function. The first and easiest is called the power rule. The basic concept with this is that you simply multiply the numerical value of the exponent with the variable's coefficient. Then you subtract the exponent by 1. This resulting function is the derivative labeled with the prime symbol. This rule applies for any term with an exponent as long as another term is not being multiplied or divided. In a polynomial, such as a quadratic function, you can do the power rule separately on each term and then add them together. For the last term, in which there is no variable, the derivative is simply 0. This is because if you have a function without an exponent, it creates a horizontal line. A horizontal line has a slope of 0 because it's a constant and does not change. Sometimes a given function is more complex and may involve simpler functions within the overall equation. For example, take this polynomial that has been raised to a numerical exponential value. In this example, the outer function is the polynomial being cubed, while the inner function is the polynomial itself. To find the overall derivative, we first use the power rule on the outer function and then multiply it by the derivative of the inner. This method of working from outer functions to inner functions within a compound equation is known as the chain rule. So far, we have only discussed deriving functions that involve addition and subtraction between variables. But what about multiplication and division? To derive these such functions, we must use the product and quotient rules. The product rule is used when functions are being multiplied. Unlike polynomials, you cannot simply just multiply the derivative of each function together. Instead, the formula for the product rule states that you must multiply the derivative of the first function by the second function, and then add this to the product of the first function multiplied by the derivative of the second function. The quotient rule is similar, but is used for functions that are being divided and is usually split into a top and bottom equation instead of first and second. The formula for the quotient rule, like the product rule, tells you to take the derivative of the top function multiplied by the bottom function and then add it to the product of the bottom derivative and the top function. Then you take that entire sum and divide it by the square of the bottom equation. Both the product and quotient rules can get a bit messy depending on how complex the function is. Always make sure to be following the chain rule, even when using the product or quotient rules, because they are often intertwined. The key to solving these sort of complex functions is to keep track of each of the functions within each other. Sometimes it may be beneficial to first label each simple equation within the compound with terms such as f of x or g of x. Rewrite the compound using these terms and derive using the terms as well. Then you can find the derivatives of each simple function and then plug it into the overall derivative formula that you created. Just when you thought derivatives couldn't get any more complicated, some special functions have their own special derivatives. Unfortunately, there is no easy way to know these derivatives without getting involved in even more complicated and confusing math. The most efficient thing for you to do is simply memorize. The trig functions are quite easy. The derivative of sine x is cosine x, and the derivative of cosine x is negative sine x, because cosine always has to be extra. Then we have your sexy tan rules. These rules are really just devices to help you memorize the derivatives of tangent and secant, and they are as follows. First, since tan people have sex a lot, the derivative of tangent x is secant x squared. And second, sexy people also have sex with tan people, so the derivative of secant x is tangent x multiplied by secant x. The derivatives of cotangent and cosecant are the same, but are negative, and use cotangent and cosecant in place of tangent and secant. The inverse trig functions get a bit more complicated. The derivative of inverse sine of x is 1 over the square root of 1 minus x squared. The derivative of inverse tangent x is 1 over x squared plus 1. The derivative of inverse secant x is 1 over the absolute value multiplied by the square root of x squared minus 1. The derivatives of cosine, cotangent, and cosecant are the same as their no copartners, but once again are negative. So aside from polynomials and trig functions, there are just a few more special functions. My favorite special function is e to the x. The derivative of e to the x is, well, e to the x. Now the derivative of an exponential function, let's say a to the power of x, is the original function multiplied by the natural log of the constant a. The derivative of natural log of x is 1 divided by x, and the derivative of log base a of x is 1 divided by x times the natural log of a. The hardest part about these special functions is that you must still remember to use the chain rule. In certain circumstances, these special functions may also be integrated within derivatives using the product, quotient, and power rule. For example, if you are asked to derive the function of natural log of x to the fourth, you must first take the derivative of the natural log, leaving you with 1 over x to the fourth, and then multiply by the derivative of x to the fourth, 4x cubed. You may be given functions such as sin x divided by 7 to the 2x power. This would require you to use the quotient rule while also knowing the derivative of sine and exponential functions, as well as being able to correctly chain rule. But once you know the basics of derivatives, these complex functions all become possible to derive. Now there is no rate of change you can't calculate, except the ones taught in Calculus BC that I have yet to learn. But I hope you enjoyed this crash course on calculus derivatives, and have a nice day.